Okay, so welcome everybody to the 8th WasmEdge community meeting. These are, of course, held on the first Tuesday of each month at 11 p.m. Hong Kong time. And we are joined today by many participants in here, which is great. And the presenters, we're going to have Hydai, who's going to talk to us about how to write a WasmEdge plugin in 0.10.0. And Michael is going to talk to us about a Reactor demo, essentially a serverless SaaS API. All right, so just touching in with Hydai. How are you, mate? Are you ready to roll?
Oh, okay. Let me share my screen first.
Okay, so Hydai's going to share his screen and take it away. Thank you.
Can you guys see my screen?
Yes, excellent.
Okay, great. Today I'm going to present that how to write a WasmEdge plugin. The WasmEdge plugin actually is from our previous interface. We have defined lots of the host function interface for the developer, so they can create some host function. For example, we have the WasmEdge process, which is just simulate something like you can create a bash and execute like list your folder, or you want to create a folder, and even you want to code the other external binary, that's fine. And also we use the same interface to create our TensorFlow extension. So you can load the AI model from the Watson application. You can do some image inference from the Watson application. Okay. However, the origin design is statically linked, which means that if you want to use the WasmEdge TensorFlow, you have to download another tool called the WasmEdge TensorFlow toolset. And our module release do not contain the TensorFlow extension, so you will get the pure WasmEdge tool. So if you want to, you want to use lots of different extension, you have to download lots of corresponding tools. They will be crazy once we just extend our extensions. So we want to do a big change, which is transfer the host function into the plugin system. So with the plugin system now, you can just create lots of plugin and make them just dynamic load in the initialized time. Okay. So how it works? Actually, you will put lots of your plugins in a specific folder. For example, in our original design, you will put in the WasmEdge default install path, which is the .wasmedge/plugin, or you can use the environment variable to set the path. Okay. Once you put your extensions in the folder, whenever the WasmEdge runtime or the WasmEdge SDK will try to load all of the plugin in the folder, and then you can use your your Wasm file if you have the corresponding module name and their module function, then just import them and call them. So for example, if you want to use the TensorFlow, you will import TensorFlow and, for example, do some inference. Okay. So this is a big picture of how the plugin works. And now I will give an example, which is create a very simple application called getString, which can make you pass a string from the command line interface and then just print the string, and you can also append more options to make some change or make some configuration to the tool. So in this example, we will demonstrate the following things, which is how to register the plugin with the given name. So please notice here, you will have lots of plugins, so which means you will have lots of modules. So the first thing is that you have to define every module name, which is very simple because this is a unique name, so we can link it when executing the Watson application. Then every plugin, we believe you may have lots of options. For example, our WasmEdge process will create a whitelist. So you can allow the user to use a specific command line. So the user can do some dangerous thing, for example, remove the root directory, yeah, something like that. So the second one is we will tell you guys how to add options to control this. And then we have some options which can make you bypass some default value or some configuration from the command line. Then we will show how to call the relative host function from Watson application. And before we start, this will be the 0.10.0 alpha version, and unfortunately, because we are just fix some minor bugs, so we do not release it now. But we believe this can be made by this Friday. So if you want to try it now, you have to switch to the this branch to get the latest code. And this week we will have this release. Then you can just follow the WasmEdge book and do the this example. So the file structure is very simple, which is you will create a folder with your plugin name in the plugin folder, and you have to write a CMake list because you may need to build and link some library. For example, if you want to use the TensorFlow, you have to write some, pen some header and link some library in this file. Then you will have a file to make your plugin implementation. Also, this name is nothing. You can just rename it to anything, and you can have lots of the CPP file or header file. That's fine because we will use this this CMake file CMake list to compile all of the files. Then in this folder, we will have two files just for the demonstration, which is the test Watson to call our host function, and this is the just the same file but in the test format. Okay. So the functionality of the get string example, which is you will give a string to our command line, and then if you do nothing with no options, then you will just print the given string. For example, the first example, if you use the WasmEdge with designated string, this is the first option, which means you can bypass a string to the plugin. So we have this option to bypass the 1, 2, 3 hello, and then we just print it. And also we have just want to demonstrate that you can not just pass in a string, you can pass a boolean or an integer. That's totally fine. So in this example, we add a upper option, which will convert all characters into the uppercase. For example, if you use the upper option, it will print the 1, 2, 3 hello, but in the upper cases. Okay. So the test Watson is very simple. Sorry, can I just make bigger? I'm not sure if this is clear or not. Just make bigger. Okay, so the most important thing is this first import, which will import the module Watson name, which is the host function module name. You just register in the plugin, and then this is the real function name in your definition. Okay, so when you have multiple functions, multiple host functions in your module, then you will have multiple line of the import. You will import lots of the functions from this module Watson name. And just for the demonstration, we have to use two WASI function. The first one is we will use the FD write to print the string to your console. Then when we want to access this function, we will call the process asset to leave this function. So it will be very simple application, just a main function called start, and then you just get the string from the command line and set the buffer, and just write the buffer and print and then exit. Okay. So in this example, we will have a very basic interface, which will be, you will have a function called add options. This will allow you to append some related option in your plugin. For example, the string and the upper in this example. And then you will have a plugin module, which is inherit from the runtime instance, module instance. This is the real module instance. So you will register lots of the host function in this constructor. And please notice that the module Watson name is defined here. So if you want to call it TensorFlow, just modify it here to TensorFlow. This must be a unique name. So if you have multiple plugins, please do not use the same name, or you will have multiple definition and make some ambiguous case. Then you will have a create function, which will just the constructor to create this plugin module to return. And the next part will be you have to define a plugin descriptor. This is very simple. For example, all of the metadata is here. For example, this plugin name and the description. For example, you can write lots of description here, and the API version, because the plugin interface may change. So this is very very important version for WasmEdge to check if the plugin is compatible with the previous version. And this version is your plugin version, so you can have 0.0.1 or something like that. And please notice that you will have, this is a plugin name, and this is the module descriptor, which means the design of our plugin is possibly have, for example, our TensorFlow plugin will have multiple modules, including the image module, which can make you load the JPEG or the PNG files. And then you have another module called TensorFlow and another module called TensorFlow Lite to do the related things. So there may be lots of the modules. So you will have define the module count here. Okay, then call the plugin register to register your description. So that's the basic interface. And after that, you can add lots of the options if you want. And we use our PO option data structure, which can make you create the option very easily. For example, if you want to create a string option, you will have something to fill. So the first one is the option description and the meta verb, and also the default value. So this will be shown if you use the dash help. You will just list you have for example the string option, the upper option, and the related descriptions. And after you define the option variable, then just add them in the add options. You will call the parser add options. Just add the relative name and relative object. For example, the string to string option, the upper to the upper option. Okay. Then you will have implement the getString function. This will be some detailed, but I will just mention it very quickly. So all of the functions will inherit this template called runtime host function, and you will have your class name here. You can have any class name here, and this constructor you can also customize it. That's fine, because we will when we execute this host function, we will use the body function, not the constructor. Okay, the constructor is just for you to set the some configuration, something like that. Okay, so the most important part is that you need to implement the real functionality in the body function. Then the first parameter must be the memory instance, because for example, you want to load some string from the memory, then you will use this this module, use this memory instance. Then the remaining part is the real real parameter of your string, of your host function. For example, you will have a buffer point and the buffer length, and you will also have the return pointer. Okay, so that's the detailed. We just skip them. Okay. Then after you finish your host function, you will just add it in your plugin module. In the right side, you will call the add host function. Then you will function name. Please notice that the get string must be the same in here, this function name, because we use this this conversion to check if the import is correct or not. So please notice this module wasm name, the get string must be the same as your wasm file. Then just register the function body. For example, we will set the string option and the up option here. Okay, so you can find that we create the get string object and with his constructor. Okay, after we do this implementation, then we just need to create a CMake list file to create this library. For example, this is a getString library, and so the output will be the lib getString.so .share object, which is the plugin file name. Okay, then you will need to have some compile option. For example, you have to define this is a WasmEdge plugin, and if you are on Mac OS, you will have to link to a special link option. We are this will be, I believe this will be fixed in our next release, because we are trying to man this link upstream as a default value. But for now, currently you will have to write it in your CMake list. Okay. Then you will have to, include some directory and then link some WasmEdge system if you are use, for example, because you use the module in WasmEdge, you also use the mirror instance in WasmEdge. So you have to link the WasmEdge command and WasmEdge sys. Okay. So after you do lots of the C++ things, then now you can compile it and run it. So here is the command line for you to to reproduce the full example of our example. So the first thing is that you clone our WasmEdge project, and for now, just you have to check out the plugin doc branch, or after we release, you can use this tag and just create the Ninja configuration, build it, and create the plugin folder. Then you have to copy the this one, the lib get string, which is generated from our previous example, to the plugin folder, and then just execute it. Okay. So let's our short introduce of the WasmEdge plugin. And because this is in very early stage, so if you have any feedback, please use you can just post it in our Discord channel, or use the GitHub issue to give us some feedback. We believe that's very good.
Wow, thank you, Hydai. That is excellent. Really good.
I just post the slide link to the chat, so if you are interested, you can just check the slide. Thank you.
Awesome. Thank you so much. Really, really good. Really interesting. Yeah, fantastic. Okay, I see your slides there. You posted those in the chat. So everyone, if you want to go back and have a look at those, they're in the chat right now. That's excellent. Okay, so at the end of this, we'll have some questions and answers. So if you wanted to come up with any questions that you wanted to ask Hydai, please have a think about that. And then at the end, we'll have an opportunity to elaborate a bit on that presentation. It was very good, very interesting. Excellent stuff. Okay, fantastic. So next up, we've got Michael, and he's going to talk about a Reactor demo. So essentially serverless SaaS API. So take it away, Michael.
All right. Okay. Can you guys see me? Okay.
Yep.
Yeah. Thank you, Tim. Yeah. So first of all, thank you, Hydai, for making that introduction. I think this is one of the bigger things that we have been trying to do in the project, is to make it easier to write plugins and to write extensions, because one of the most important feature of WasmEdge, the differentiating feature of WasmEdge compared with other Wasm runtimes out there, is that we provide a rich set of extensions, like Hydai said, so AI inference, the networking sockets, and all that. We are building a lot of stuff on top of those, and we want to make it simple for people to contribute new extensions, essentially new host functions. If you think about this, Java has gone through the exact same process, 20 years ago. I remember when the JVM first came out. It's a computing engine, it can only does things that are inside it, right? So it can't do a lot of things, So I remember at the time people say, I want to play a video game with Java, but you can't do that because the JVM doesn't have access to the sound card. The computer used to have something called the sound card. That's it has a native driver and all that. It's not accessible to Java. So people came up with the idea of the JNI, which I think is still in use today. Java native interface, where allows people to to write those native plugins. Then you can have a game written in Java, right? That's I think WebAssembly, WasmEdge in particular, I think is going through the same process at this moment. Is that when we are using it outside of the browser, we are using it in a cloud-native environment. We are seeing a lot of missing features. We are seeing making network calls. How do we connect to database, for instance? How do I connect to MySQL or MongoDB? How do I do HTTPS? And how do I do fetch? How do I access the GPU? And all this stuff. That's without the browser that provides things like OpenGL and things like that. You would have to access to the operating system, which is WASI, right? So we really want to make it simple for people to to actually do that, to write plugins. So we've spent a lot of time refactoring our infrastructure so that I think we're at the stage, with upcoming release of WasmEdge, I think it's going to be a lot easier because I think in the past, that's if you want to write a host function, it's kind of hassle. You have to know, you have to really understand what's going on inside the inside of the whole architecture, inside of the VM. But I think now there's a more clear separation between those elements. So I think that's one of the things that we really strive to do. And I hope that's as developers in this community that you will enjoy that too. Yeah. So so that's what's inside the runtime. So the next topic I want to cover a little bit is applications, because we always want to structure this, the meetup to be, what's happening with WasmEdge and what's happening with the applications that build on WasmEdge, right? So as we have talked again, one of the things that we thought would be an interesting use case for WebAssembly on the server is to run serverless functions. But what kind of serverless functions? That's if you look at serverless functions in public cloud, let's say in AWS, those are mostly, I think, data connector functions, meaning that it has some kind of simple or stateless logic that moves, that applies to the data in motion. For instance, one of the most common case of a serverless function in AWS is moving data from S3 to some messaging queue, something like that, right? And with the serverless function, you can apply some kind of transformation that's when the data is being moved. Moving data is one of the widely used, scenarios or applications for, for serverless functions that's in the public cloud. So we are thinking about, whether we can do something that outside of the public cloud in application space, meaning that moving data from SaaS to SaaS. So for instance, moving data from GitHub to Slack, or from Slack to SendGrid, so meaning that when events happen in GitHub, now they're sending emails, right? Could it be a Slack message, something like that, right? So there's if you think about this idea, it's a lot like one of the I think a popular application called Zapier, ZAPIER, right? That's it basically to build data pipes between services between SaaS, right? So it can connect API from one service to the API from another one, so that like I just said, something happened in GitHub, it can trigger something that's in Slack to send out a message, something like that. And I think with serverless function, we can take this to the next step. We can not only just connect those APIs, connect from output to input, we can also have a little bit logic that's in between to do the data transformation, which is essentially the same idea AWS Lambda had, because with inside AWS, you can always move data from one service to the next. But the value Lambda adds is that it's allow you to program it, right? So that you can add functionalities or add transformations to that, right? So that's that is a cloud service that we're actively building on top of WasmEdge. So what I'm going to demonstrate is a short video. It's from our live site. We're not yet ready to open it to public yet, but if you want to try it, just email us after that. And after this talk, because we do want to get people to try it. So what this demo does is that it's it allows the say a community operations person better manage their GitHub community. So think about the application scenario. Nowadays, if you have an open source project like ours, you have a GitHub repository, and you want to get people to engage in it. You want to get people to start to like it, and whatever. But when people start, they don't get any feedback. They essentially have a bookmark. That's a start repository in their GitHub list, and you don't get anything either. Because unless you actually go there and look at it, you won't get a notification. And so it's so the act of starting our repository doesn't really generate any interaction between you and us, right? So from the for a lot of communities or repositories that want to be actively managed, they may have the need to say, if someone start my GitHub repository, I want to send some kind of automated message for another call for action, or alert myself, something like that, right? So, but in order to do that, we need to capture this star action from the GitHub API and connect it to a notification or to an email API or to something else, right? So that a customized email message can be sent out. And there are also a little bit logic in it because, because based on that start event, I may do something different, depending on who's starting it, and whether this person is a person who started, now he's unstart, or a person who's who are adding a new start to this GitHub repository. So there are things like that. There are logic in it that is ideally suited for, we would think, ideally suited for serverless function. But this is just an example. So I'm going to show you this this demo now, and it is a quick video. So let me share my screen. So let me play it.
Reactor works. We are looking at it now. So it is still in beta mode with a rough UI. You're able to see Slack, GitHub, and SendGrid. These are our three connectors. These three serverless SaaS APIs are provided. You can have Slack as the inbound connector, meaning where the message or data comes from, and take SendGrid as the outbound connector.
So I'll pause here. So you guys can hear the voice, right? You guys can hear Miley's voice in this video, right?
Yeah, perfect. Yeah.
Oh, okay, yeah. So basically, we pre-build those. So we have a platform that acts as a host of those connectors. So we build those connectors ourselves, but other people can come and build it as well. So essentially, we're taking the Slack API and build the connectors themselves are WebAssembly applications, but we're going to talk about that later. But but now you can just think of those as connectors that are already built for the platform that you can use them as Lego blocks or building blocks to compose something called flow. So those are connectors. So each flow has two connectors, inbound and outbound. Essentially, you have an inbound connector that could be a Slack message or GitHub message, and then you can have an outbound connector that would do when they receive this message, it has a serverless function process in the middle, and then in outbound, it can send a Slack message out, or post a GitHub issue, or use SendGrid to send out email. So let's look at how we construct a flow from those from two connectors. Yeah.
Meaning where the data should be sent to. Next, I will show the flow between the GitHub and SendGrid SaaS. With this flow, if someone starts your GitHub repo, you will be able to get a notification email saying thank you. Okay, let's begin. First, let's select GitHub as the inbound connector, and then select the outbound connector to be SendGrid. Let's name it Test SaaS. In this description box, we can type to describe what the flow does. You can write anything based on your flow's function or your needs. Next, we need to upload our WASM file, which will implement the GitHub API so as to implement the flow's intended function. Let's see an example. These are the Reactor's examples. This start by SendGrid is the example we want. Let's open and see. Actually, here we can see it uses several GitHub APIs. The sender is a GitHub API, and the repository is another GitHub API. And then here, if somebody starts your repo, then an email will be sent to him. Here is the title of the email. Here is the body of the email. If somebody unstarts your repo, he will receive an email too. Here's the title of the email. Here's the body of the email. Next, we need to compile this Rust code to WASM file and upload it to our Reactor. Here is the code I git cloned to my local machine. It is already compiled. The code is cargo build target WASM 32 WASI release. This is to compile it to WASM file. I have already compiled it, so we will skip this step now. And let's find the WASM file and copy the file path of this WASM file. Upload this WASM file to Reactor and then create. The name already exists, so I cannot use the same name. Let me change to another name. Next, we need to select which repo under which organization on GitHub we want to point.
So I'll explain a little more. So now you can see we now have a flow. The flow has an inbound connector. It receives message from GitHub, and it has a function that in the middle, it processes that GitHub message into an email, right? And then it has an outbound connector, which is SendGrid. So for this WASM application, all it does is that takes the input string and output the output string. You know, essentially because it gets from a connector and then it goes to another connector, right? So that's the entire flow. So it's two connectors with logic with a function in the middle, right? But now what we need to do, because for most application, most SaaS, you can't just have a connector because the connector is generic. In this case, you got to tell GitHub which repository you need those events from, right? You know, because that is from your own account, because you would only have access to the GitHub repositories that you have access to. So we need to. So once we set up this flow, we need to configure at both ends. That is exactly the same process as that here as well. And SendGrid is the same. You know, it needs to send from your the from address needs to be yours. So it's you need an access token that you get from SendGrid, right? So let's see how it's done.
Later. Let me choose Alablay. Alablay is my own GitHub ID, and we choose a repo. I have set a test repo, so I choose that. Now it is connected. Let's go back to the Reactor page and configure the SendGrid. On the SendGrid configuration page, we enter the email we would like the email to be sent from and enter the SendGrid API key. Now we have the configuration ready. So we have connected the GitHub Observer with the SendGrid, and the flow from GitHub to SendGrid is created. Next, let's go to GitHub for a test. This is the test repo I set up just now. Let's start this test repo. And next, we go to my email to see if I have received an email. Okay, just because now I have started the repo, so I can see the Reactor has sent me a thank you email. This is the same content I entered just now. Going forward, WasmEdge will support using JavaScript to implement code for business logic. Please stay tuned.
Yeah, so that's let me see. Yeah, so as you can see, there's still some rough edges. When you select the GitHub repository that you want to connect to, it doesn't show. You have to go through another tab. and it doesn't show on the main UI. And now, the serverless function compared to Wasm, you have to write it in Rust at this moment. Essentially, using Rust to pass the inbound JSON message and format another JSON message to go out, right? And things like that. But as Miley has said in that video, that's something we are working on. That's our goal is relatively short term. Maybe maybe in a week or two. We're going to support JavaScript-based serverless functions, essentially using the WasmEdge QuickJS setup, so that we can allow JavaScript users to because it's a lot easier to pass JSON in JavaScript. It's just set up that way, right? So it would be, I think the developer experience is going to be improved a lot, by having by supporting JavaScript as those functions, and we're going to continue to improve that UI, so that it become more intuitive for people, and also adding more connectors, because I think we are at the point where now you see 3 connectors, but there's perhaps hundreds of SaaS or services out there, and each of them has open API. So it should be this is something that we want to engage our community, students maybe, to contribute to those SaaS connectors, so that we can essentially connecting any 2 SaaS services in the world, and adding some logic, adding a serverless function in the middle. So yeah, that's well, that's what I want to show you. That's we're super excited about this, because this is something that we feel going to be useful for a lot of people, and we'd love to get your feedback and also your contributions, as we roll it out. And like I said, if you want to try it out, just send us an email, and and we're gonna get you set up for access on that platform. Yeah, thank you.
Yeah, excellent. That's fantastic. So any questions floating around at the moment? Anybody got anything? Just feel free to jump in, just unmute yourself and talk away. I'll just mention also, this week we have been tweeting. So as you probably well know, the WebAssembly version 2.0 draft has come out, and I just want to direct you along to the Twitter account for WasmEdge. So if you go to twitter.com/realwasmedge, so REALWASMEDGE, real WasmEdge, you will see there that we've got a series of tweets. And what we're doing is we're essentially going to the version 1 specification, and we're looking at that. And these are about 220 pages or thereabouts. And then the version 2, which has just been released a few days ago, we're looking at that, and we're comparing the version 1 to the version 2 and pointing out the differences. So if you go to the Real WasmEdge Twitter account, you'll see we've already got a few. We're doing approximately about one tweet a day there, and we'll just continue to do that as time goes on. Things like changes to data types, how they've introduced new sections like security considerations and things like that. And we'll do our best to post. Obviously, the tweeting is a bit restricted in characters, but we'll do our best to point out what's new in 2.0, and then maybe like a little image or a screen capture or something like that, just to give you a nice little nudge to go. If you're interested, you can maybe then go to the docs and have a look. The first tweets that we sent out was actually links to the specs, like the web API, and also the core specification, but also the online version, which is indexed. And so you can actually go through a list of keywords and search. And then the other thing we put there was there's a link to an actual PDF document, which is that 200 and something pages long. You can actually just download it as a PDF, which is super handy, whether you want to have something like Speechify read that to you, or whether you want to Control F and search through the document quickly. But there's also, of course, an online version, which is just HTML based. That actually works. It's hyperlinked, so you don't get everything on the same page. You sort of always clicking through using hyperlinks. So we've tried to make it accessible there, giving a few different modes for you to read. A very big but very interesting document about the Twitter WASM specification. So feel free to check that out. The other thing is also, if you go to medium.com, and I'll post these in the chat as well. So medium.com/WASM. Also got some articles coming out there, and you'll see on that homepage when you hit medium.com/WASM, there's a link saying become a writer for the WASM publication on Medium. This is essentially just a Medium publication dedicated to curating WebAssembly information. So if there's anything interesting that you're working on, if you wanted to write an article, big or small, we can even collaborate with multiple people, or you can just go alone and write something up and publish that. That'd be really great. You'll see a bunch of articles there. The latest one is based on a previous talk that Michael did. It's the server-side rendering using WebAssembly. So we're trying to just use Medium as a medium to elaborate on ideas and add richer content and code and images and videos and things like that. You'll see a whole bunch of things there from the past, going back through how we use Dapper and how we've integrated certain things, Jamstack applications and this and that. So yeah, feel free to check that out and feel free to follow that. And then also with the twitter.com/real_WasmEdge, feel free to follow, keep up to date with all the latest happenings if you're not already. So in the meantime, anybody got any questions? Well, that's around about an hour, which is perfect. Thank you everyone for joining us. Great talks there. If you have any questions or you need any information, like Hydai says, please go to the GitHub issues. You go to the actual repository where you're working, you can post something in there and we'll get onto that straight away. And of course, you can contact us via email. So please keep in touch and let's collaborate and build great things together. Thank you so much for joining us.
All right, thank you.
Okay, bye everyone.
Good.
Thanks. Bye.
Bye.